Students to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you all to part 2 of a session for lesson 7.6 solving system of equations using Cramer's rule. Okay, so moving on in the lesson for today's session, we are going to be knowing a formula that will help us to find the area of triangle using the concept of determinant. So in our last video, we had seen in part 1 how we evaluate determinants of second and third order. If you have not seen that video, I would urge you to first watch that video so that you know how we are going to evaluate the determinant of area of triangle. I'll put the link in the description box and you can press the card on top of this video to watch that one before today's session. Okay, so moving on with part 2 in our today's session, our learning objective would be to find the area of triangle using determinants. And in today's session, I'm going to start off with giving you a formula that will help you very easily and very quickly using determinants to find the area of a triangle. Given in the question, the 3 coordinates of the vertices of the triangle. So let's get into the video, and a humble reminder, if you've been liking and watching my videos, especially for the grade 10 series of term 3 that we've started with, don't forget to hit that subscribe button and press that bell icon. Also, in the coming days, we are going to focus on grade 10 more topics. So let me know in the comment section which more videos you will find useful for your coming continuous assessments and exams. I'm sure many of you must be having this question in your mind that why you are learning determinants. So as we proceed in the videos and in the lesson, you would see that one important application of knowing the concept of determinants in being able to evaluate its value would be to find the area of triangle. So there's a formula, a kind of a shortcut, which is quite important here for all of you to know. So if you are given in the exam, in the question, the coordinates of the 3 vertices of the triangle, means you are given A, B and C, the 3 coordinates. Now here if you see, they have taken A, B, C, D and E, F. So even if you have x1, y1, x2, y2 and x3, y3 as the x and y coordinates. So these are the ordered pairs we are talking about. I want you to recall that in the coordinate geometry, in the xy plane, x comma y represents a ordered pair. So the first value would give you the x coordinate, the second will give you y coordinate. So these points, just like in this example, the figure, the triangle that you see will be given to you. So 1 coordinate, 2 coordinate, 3 coordinate. So from the question, you will be getting the value of x1, x2, x3, y1, y2, y3. Or if you see the formula in terms of ABCD, this is the one. So what will be the area? The simple way of doing this calculation would be the shortcut of the formula, that area of the triangle with these vertices is equal to 1 by 2, the determinant A. So first you write the x coordinates A, C, E in the first column. So C1 consists of x coordinate, C2 consists of y coordinate, so B, D, F, and C3 is always 1, 1, 1. So C3 is fixed, you'll keep it as 1. So for this triangle, if you look at, the x coordinate is -4, -2, 3. So you follow the order, okay? Just don't make that mistake that first you're taking this, then this, then this. So either you follow this order, or if you're starting from this point, you follow this order. So one way you need to take, so -4, -2 and 3, that's the first column for the x coordinate, 3, -2, 1, and you follow the same order. Means if you're writing -4 first, you take its corresponding y coordinate. Okay, so don't mix the order, that's important. And last column is 1, 1, 1. Now in the last video, you've already seen how to evaluate the determinant along the first row R1 for a third order. So you may simplify this to get your area. So let's take a very simple example. For example, you have a triangle ABC and the coordinates of this triangle are, say, 5, 8, -3, 7 and 0, 2. Okay, these are the 3 coordinates, the 3 vertices of the given triangle, and you need to find area of triangle ABC. So let's use determinant. So the formula is 1 by 2, determinant x1 below it x2, x3. So x coordinate comes in the first column, then y1, y2, y3 comes in the second column, then 1, 1, 1. These three coordinates. So let's just plug in the value 1 by 2. So x1, now I'm going to change color and just highlight. So this is my first coordinate x1, then x2, then x3. Okay. In a similar way, this is y1, y2, y3. So let's plug in everything inside. So 5 minus 3, 0, 8, 7, 2. And the last column, C1, always remember, is 1, 1, 1. Now this is what? This is a third order determinant. So you are going to use the trick that I taught you in the last video. In case you have forgotten or you have not seen that video, I would highly recommend you to see that so that you know how we are opening this determinant across R1. So first we write 5, 8, 1, the three elements separated with some gap in between so that we can write the second order determinant. Then we select the sign. So first is positive, only middle term gets a negative sign, remaining are positive. Okay, I'm putting these big brackets just to denote the determinants. Now let's fill in the value. So for 5, I remove R1, I remove C1. So inside 7 to 1, 1. For middle element, remove R1, C2. So negative 3, 0, 1, 1. For the last one, remove R1, C3, the row and column containing that element. So these four are left, negative 3, 0, 7, and 2. Now we just use the diagonal rule. First primary diagonal, then you subtract the product of secondary diagonal. We do that for all these three matrices of second order. So 1 by 2 outside, 5 times, what do we have? 7 minus 2 minus 8 times negative 3. This is already 0, nothing comes, plus 1 times negative 6 plus 0. Again, you don't have anything here. So let's simplify. 1 by 2, 5 times 5 plus 8 3s are 24 minus 6. Simplify more. 1 by 2, now this is 25 plus 24 minus 6. So this is like 49 minus 6. So this is 43 divided by 2. Now 43 divided by 2, since we don't have any units given, we can just like write the square units. Okay, so you can I have left the answer in fraction. You can convert to decimal also, but I hope you understood the application of the formula using determinants to find area of triangle. Let's now do some textbook question. The question that I'm taking now is given in your math book on page 47. It's a solved question, a real world application. So I'm just going to explain a little bit about it to you, and you can just simply follow the same method I've taught you in the last slide to get your answer. Okay, so here you are given 1, 2, 3, 3 points. You can refer to the question from your book. It was given at the beginning of the lesson, and the coordinates of the vertices of the tiger territory are shown to the right. So 1, 2, 3, these are the 3 points. You need to use determinants to find the area of the triangle territory. So you are going to use the formula, the shortcut that has been shared to you in the beginning of this video, and now I want you to observe the x coordinate is 0, negative 0, negative 2, 4, these two. Then for y coordinate 0, 8, 12. So you follow one order. So what order they have taken here? They have taken first 0, then 4, then negative 2. This order they have followed. So 0, 4, negative 2. And then next is 0, 12, negative, plus 8, and then 1, 1, 1. So these three coordinates have been selected. Now the method used here for simplifying the determinant is called diagonal rule. If you find this method confusing given in your book, please follow the method which I've given you as in the previous example and in my last video. And when you simplify that nicely, the area of the tiger's territory will come out to be 28 square kilometers. That was a solved example. Please go through it, and now we'll look at one unsolved question. Okay, so this question I'm taking again from page 47. It's an unsolved guided practice question, and let's check your understanding by solving this question together. So 1, 2, 3. Three coordinates are given. Let's write them in the ABC triangle form. 3, 15, 6, 4, 11, 9. Okay, so these are the 3 points. We first need to find the area of the neighborhood where which is made by these 3 points. That means we need to find area of triangle. So what is the formula? Formula is 1 by 2. You take the determinant. We are going to use determinants. X1. Just let me remove this. Yes. So x1, x2, x3, column 1, y1, y2, y3, column 2, 1, 1, 1. So if I'm going to write using determinants, what I'm going to get, last column is easy. Let's write it first. Then we have to take x1. So x1 is this, x2, x3. So 3, 6, 11. And corresponding y is 15, 4, 9. 15, 4, 9. So let's evaluate this determinant. You already know how to. So I'm going to go a little fast now. We are evaluating across first row. So 3 times. I remove this row, remove this column. 4, 9, 1, 1. Minus 15 times. Remove this row, remove this column. 6, 11, 1, 1. Plus 1 times. Remove this row, remove this column. 6, 11, 4, 9. Okay, let's simplify it further. We are going to now use diagonal rule. It says first you evaluate primary diagonal, multiply, and then subtract the secondary diagonal. So we do that for all the parts here, and what we get is 4 minus 9 minus 15, 6 minus 11 plus 9 multiplied with 6 minus 44. So let's simplify this more. Do our calculations correct. So 3 times negative 5 minus 15 times negative 5 plus here 9 6 54, and you subtract 44. So we are just left with a 10. I can simplify this more. So now I'm going to just do it quickly and connect all the terms which are common. So 15 times 5 would give you 75, and negative will cancel to give you positive. So how much is this? It is 85 minus 15. So this is 70 divided by 2. So 35. Now if you check 35 units square, this has come out to be the area. Now you are given something more. What is that? Each unit represents 0.5 kilometer. So the area that you need to give should be in the units of kilometer square. Okay, so I will write here the unit for conversion. 1 unit is how much? 0.5 kilometer. Okay, and how many units you got here? 35 units. So let's see how it is going to change. That means 1 unit square is going to represent how much? Let's do. So it is going to be the square 0.5 multiplied with 0.5. So it is going to represent 0.25 kilometers square. Okay, now 35 units you got square. So how much it is going to represent? 0.25 multiplied with 35. So let's do this calculation, and this will come out to be what we need. So this is 8.75 kilometers square. So what extra part we have done here? It is just the basic arithmetic that that you already know, and we have done here something called as unit conversion. So the unit of area that you got by solving the determinant was 35 units square, but you needed the answer in kilometers square, so you use the conversion that 1 unit is 0.5 kilometers, and then you squared both sides to get 1 unit square equal to 0.5 multiplied with 0.5, so the conversion factor was 0.25. So just multiply it with the area, and what you get is your area of neighborhood in kilometers square. Now I'm going to give you another important question, but I'm not going to be solving it completely for you. I'll leave this question on to you with a hint. Again, this is an unsolved question of your math book, and this one is given on page 50, and it talks about examples 3 to 5. And it talks about Bermuda Triangle. So Bermuda Triangle is actually the area that is formed by the southern Atlantic coast of the United States and is noted for reports of unexplained disappearances of ships, small boats, and aircraft. You may just Google about it if you want to know more about the Bermuda Triangle. It's a very mysterious concept, and still a lot of research is going on. So what you need to do for part A, you need to find the area of this triangle that's given on the map. So if you see this triangle carefully, it is formed between Miami, Bermuda, and San Juan. So you are given the x coordinate, the y coordinate. So think about what should be the coordinates of these 3 points. Once you know their coordinates, you can always use the formula for area of triangle using determinants. That way you are going to get your area of the triangle, just like in the last problem. After that, in B part, you need to do the unit conversion. Each grid is representing 175 miles. So you need to convert the area that you get in step A into miles square. Okay, so that way you'll get the area of the Bermuda Triangle. Coming up next on my channel is part 3 of this series of lesson 7.6, solving solutions or system of equations using Cramer's rule, and the next video is a must-watch video for all grade 10 students. One question will surely come in your exam on solving 2x2 system of linear equations using Cramer's rule. So stay glued to my channel and hit the subscribe button and press the bell icon to receive notification of my next video. So that's all for the session today. Thank you for watching today's video. Hit like if you found the video useful, and please quickly subscribe to the channel if you're watching and liking my videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.